So the last time that you were with us, we did this foldable right here, one-step equations. We did the inside of it. So today we're going to look at the back, and there are some exceptions to our general rule of doing the inverse operations. Specifically, I call these problems dirty rats. And you're going to see them with subtraction or possibly with division. And so I'm going to divide this about in half right there. Just keep that in mind. We're going to put subtraction up here, and then we'll do the division one down here. So the dirty rat would look like something like this. 4 minus x is equal to 3. And what's different about it is that it is subtracting the variable instead of this number, the constant. Okay? So if you think about it, common sense tells you that 4 minus 1 is 3. Common sense tells you that that solution is 1. However, what if we had something like 41 minus x is equal to 29? Well, that's not something I typically know right off the top of my head. I don't know that subtraction fact. You've got some options, okay? So here's option 1. You can add x. I should have put option 1 up here. You can add x to both sides. And you're going to have 41 now equals 29 plus x. And then if you subtract 29 from here, we get 12 is equal to x. You can do it that way. Option 2. If we're dealing with 41 minus x is equal to 29. You've got to keep in mind what is being done in front of that variable, what is being done in front of that constant. This constant right here, this number, is positive. And to get rid of that, I'm actually going to subtract that 41 from both sides. Now this is going to send me to unhappy negative land. Okay, so if you're comfortable with negatives, this is a good way for you to go. If you're not, you should probably stick with option 1. Okay, I have this left. All right, sorry about that. My camera froze on me. This is what I have left. I have a minus x left. So bring that minus x down. If you make a mistake, that's where it's going to be. You're not going to bring down the minus x. Now, 29 minus 41, that is negative 12. However, we don't want to know what negative x is. We don't want to know what the opposite of x is. We want to know what x itself is. So, to get rid of that negative, you've got an option there. You can multiply by negative 1. Make sure you do it to both sides. And you get, for this particular problem, x is equal to 12. So there's two options for how to handle subtracting a variable. This is the dirty rat for subtraction. All right. Now, let's move on to the dirty rat for division. That would be if you're dividing by a variable. So if we had 60 divided by n is equal to 12, common sense tells us, I know that's 5. But what if it wasn't something that was common sense? What if you did not know? What if it was 51 divided by n is equal to 17. I don't know right off the top of my head what 51 divided by some number equals 17. I'm going to have to figure this out. So here's option 1. You could multiply both sides by the variable. And that gets rid of that weird dividing by the variable thing. So 51 is left over here, and now 17n is over here. Now this is a one-step multiplication equation. I can do this. Divide both sides by 17, and then you find out that 3 is equal to n. That's option 1. Option 2 is if you understand fact families. That if 5 times 12 is 60, that means that 60 divided by 5 is 12, but also 60 divided by 12 is the number that we're looking for. So thinking about that, if we had 51 divided by n equals 17, I could do this. I could switch the places of the variable and this number over here and find what 51 divided by 17 is and find my missing value. And it is 3. So that's another way to do it. And that is how we deal with that dirty rat of when we are dividing by the variable. That's all I have for today. Thanks for listening.